Hi, everyone. Thanks for having me. I do have a favor to ask because not last time I was here, but 2 times ago, I got disconnected 3 minutes into the presentation and gave the whole talk without realizing there was nobody out there. So I'm going to ask Craig to make a noise every time he sees me change a slide.
Boop.
That works. Preferably nothing obscene. This is a family channel. So let's dive in.
Boop.
My name's Michael Lucas. I've been using Unix now for over 30 years. And if I had known that Unix was going to change my life, I would have noted the date I got my first shell account. But somewhere around 86, 87, I've been a sysadmin since 95. I'm a founding member of the Southeast Michigan BSD user group, which is meeting online these days. And I want to thank Craig for that lovely introduction, but I don't know how he missed the novel Git Commit Murder, because that's clearly for you people.
I did. I'm sorry. I blanked.
Yeah.
You have such a tall oeuvre, so...
Yes. Well, that's... that would be my problem, yes. So, let's talk about DNSSEC. I'm going to try to get through this in about an hour, because I think that's about as much time and energy anyone has for this kind of talk. We'll be discussing why DNSSEC is important, what you need to run it, the records involved in DNSSEC and how to look at them, how to sign zones, how to troubleshoot them, rolling over keys, some basics on bind policies, and a couple other things. So, what's the problem with DNS? Why do we have DNSSEC? DNS is gullible. It was created in 1983, and it was meant to replace the hosts file. It did a great job of that. But at the time, the only thing on the internet were college students and nuclear missiles. That network had a very different threat profile than this mess we have today. It was meant entirely for a friendly network. There was a famous April Fool's prank where someone forged a message saying, "Hi, we're the Kremlin and we're now on the internet." And the guy posted that on April Fool's and went off to bed and came back to discover the entire internet had freaked out because this should not happen. So, very different network. DNS security extensions add cryptographic verification and a chain of trust to DNS. That sounds great. But it has a kind of bad reputation. It was first created in the early 90s, and back then it was difficult to run. The software was iffy, the standards were in flux, and if you break DNS, everything breaks. It scares people, and the collective wisdom became that DNSSEC sucks. And to be fair, the early versions were legitimately difficult. A lot of the early software really was crap and needed a lot of automation written around it. And those old how-tos from the 90s never die. If you go searching for instructions, you may find something written decades ago that is simply no longer relevant and is full of horrifying warnings. Add that to the mindset of it's always DNS, and nobody wants to touch the stuff. So if you want to experiment with DNS, you guys still there?
Still here.
Okay. Sorry, paranoid. There are some things you'll need. You have to have a test zone. Back when DNSSEC was first invented, zones were $100 a year. There is now no excuse for not buying some stupid domain to use to play with. You need a registrar that supports DS records. Most do. Domain.com does not, but that's not the only reason to avoid them. You need a DNS server that you've secured. Filter out unwanted traffic, get rid of SSH passwords. You want separate authoritative and recursive servers, and you need to secure the zone transfers between your primary and backup authoritative name servers. This could be with TSIG or whatever protocol your name server supports, and you need a correct clock. You don't have to use NTP, but you need a way to nail down the system time to within a minute or so. You need to already know some DNS basics, that there are different kinds of records. You have to be able to manage boring, unencrypted DNS before you can dive into DNSSEC. So let's talk about how DNS Sex secures traffic. There is a root zone trust anchor. It's coded in the software, but it can be updated. This trust anchor signs the root zone. The root zone signs the records for your parent domain. Your parent domain signs the records for your domain, and your domain signs individual records. All of this is based on keys. There are a couple ways that you can set up keys. Originally, and for many sites now, they used two keys, a key signing key and a zone signing key. The parent zone signs the KSK signs the ZSK, and the ZSK signs records. This is cryptographically solid and can withstand concentrated attacks. For many of us, like on my personal domain, we can get away with just one key, the combined signing key. And each key has a tag, a short numerical identifier that's unique within the zone. You also need to know about some basic DNS records. The RR-set record is not specific to DNSSEC, but many people don't really realize what it is. And it's important because DNSSEC does not sign records. It signs sets of records. And a set of record is everything you get when you make a particular query. If I ask for Google's website's IP addresses, I get 6 answers. That is an RR set. If I go looking for my website, I get 1 answer. That's also an RR set. They are complete sets of records. There's also the DNS key record, which is the public key for your KSK or ZSK or CSK. There's the DS record, which is how your parent zone identifies the DNS key record in your zone. And we'll look at more detail how these fit together. And then you have the signature record, the RR-SIG. And this looks like a bunch of stuff, and it is, but the important thing I want you to note here is that the validity dates are encoded right at the front of it. You will also see an NSEC record. Now, authoritatively declaring something does not exist is exactly as important as saying it does exist. And if I make a query, say here for systemd.mwl.io, I don't have that, but DNSSEC will spit out the next valid record. Now, yes, the obvious thing is people could use this to walk all the entries in your zone. There is something called NSEC 3 that hashes record names for privacy. Okay, given all those records, how do they fit together? Well, here we have the complete chain of trust. At the top, we have the trust anchor. That is a key signing key, DNS key. It signs the root zone's Ksk record, and that's used to sign the root zone's zone signing record, DNS key record. And in the root zone, we're going to find a DS record for the IO zone. And this points us down to the .io zone and the Ksk in that zone. The DS is the hash of the Ksk, the next domain down. Ksk signs the Zsk in the zone. And inside the IO zone, there's a DS record for my zone. That takes us out of the IO zone and down into MWL.io. And I just have a CSK there. And supposedly the hash in the DS record still matches the CSK in my domain. And that record signs the resource record for www.mwl.io, and you get a secure answer. Now, this is how a human being would look at the chain. In practice, the software builds the chain of trust from the ground up. If you open your browser and you point at www.mwl.io, your resolver will go, okay, I have already looked up the .io record. So the first 5 steps I've already done, and they're still in cache, and the caches are still valid. So I just need to grab this DS and the local zone record. So it's not as bad as it might look. So, oh wait, I made up nice little slides for each of these. So at the end of all this, you can send me email securely, and that's great. And then the email gets compromised by something having nothing to do with DNS. But this whole process is called validation. So we mentioned private keys. Sorry, we mentioned public keys. What about private keys? Yep, I can still see your icon, so I'm assuming you're there. So if someone steals the private key that goes with your public key, they can create valid DNS entries for your zone. How do you protect that and keep that from happening? Well, there are basically 4 methods. Offline signing, where you have a vault where you keep the key securely disconnected from the internet, and you take your zone file over on a USB and plug it in. This is the method that the trust anchor uses to sign the root zone. And there's a whole procedure there that is documented in RFC, and it looks like how we think nuclear missiles are launched. There's a stealth master where the host with your keys is hidden from the public internet, and the authoritative public servers are just backups of that. There's hardware security modules, which are neat little toys that will not give up your private key. And the method most people use is to pretend that this is not a problem. So let's look at some actual DNSSEC in practice. My examples are using dig. Drill is fine. Do not attempt to do DNSSEC with NSLOOKUP. NSLOOKUP has been deprecated, forked, reforked, resurrected, re-killed, folded, spindled, and mutilated until no given version of it is compatible with any other version or produces identical output. Don't trust that NSLOOKUP is actually doing what any given piece of documentation says it is, especially with DNSSEC. When you're looking at DNSSEC, you have to query recursive servers, not directly at the authoritative server. The authoritative server knows it's authoritative. It's not going to bother to do any of the validation work because it doesn't have to. It has the private key, it's signed the zone. Everything is done. So here, I'm going to poke at Google's servers. Google's do DNSSEC and hit the DNSSEC flag. And we get some answers back. And the important thing here is this AD flag I've shown in red. That means authenticated data. It works. DNSSEC has validated this answer. Now, sometimes when you're debugging, you want to look at something without, and you want to turn off validation. The domain dnssecfailed.org exists entirely to serve as a bad example. Here, you do a normal query. All the clients now by default try to validate DNSSEC. And here we get a serve fail, which means that either the authoritative name servers are gone somewhere or that validation failed. I add the CD flag and I get it to disable. A checking disabled is what CD stands for. And you see we have the CD flag in red, and then we have the no error. What this means is if I turn off validation, it works. DNSSEC is busted. So, what kind of DNS errors do we get? There's the serve fail and no error. So the kind of errors you can get include that the serve fail is the recursive name server didn't have anything in cache and could not retrieve one. Is the authoritative name server down? Did DNSSEC fail to validate? NX domain means that nothing by that name exists. And no error is everything worked, but there's no answer. Something by that name exists, but not what you asked for. Suppose I go looking for the MX record for www.mwl.io. That'll give you a no error. There's an address record for that, but the MX record is at the domain level. So there are A and Quad A records. So some useful dig options. Checking disabled, CD. Multi splits the output across multiple lines, which is very useful if you're stuck looking at these long DNSSEC keys. Plus DNSSEC shows the details. And the plus no crypto hides those long keys and signatures. So here we have, I've said, give me the DNSSEC, but hide the garbage I can't read. Okay, let's talk about signing zones. Always start with a test zone. Choose the key method that you want to use, either a single key or the Csk-Zsk combo. We'll talk about how to choose in a bit. Tell named to sign the zone. I'm using bind, as you can probably guess here. And then verify it that the signing worked on your domain and publish the DS record. So what should you use? If you're doing your first DNSSEC deployment, do the CSK. A combined signing key on your test zone is the way to start. If this is your personal zone, if this is a low impact e-business, use a CSK. My personal website has a CSK. My e-commerce site uses the stronger Csk-Zsk, but that's because I had to write the book. You should look at Zsk and Csk if words like HIPAA apply to you. Are you actually storing credit cards? What about federal regulations? Do they apply to you? Will people sue you? How about PayPal? Not do you use PayPal, are you PayPal? Use a Csk-Zsk then. Are you still there?
I'm here.
Okay. I just hadn't heard anything. Sorry. There's the whoosh now and then. Okay. So for our examples, we're going to start with the CSK. And most of you, I suspect, would go there. I know one of you in particular I know is concerned with HIPAA. They would probably decide otherwise. So DNS caches everything. So the timing of publishing and revoking keys is important. And this combination gives us a few different possible key states. A rumored key is that it's been published in the parent zone as a DS record, but it's not yet fully distributed across the internet because of caching times. You can't really count on it. An omnipresent key has been published long enough that everyone should have access to it. It should be in everyone's cache. An unretentive key is on its way out. You're waiting for it to flush from all the cache. And a hidden key is either not yet published in the parent zone or has been unpublished for quite a while. Hidden keys are visible when you use dig and start debugging DNSSEC, but they're not part of the validation process. So, key files, you rotate them, you move them out. Fortunately, bind handles the key files for you, but if you aren't using those features, those key files build up. If you decide to rotate keys every quarter, they will build up. So I strongly recommend you put the key for each zone in its own directory. here I have a directory set aside in bind just for the keys. So let's talk about zone management. There's two ways to handle zones in bind or most name servers, and that's either static or dynamic. And the truth is, sysadmins are often violently attached to zone management method. Personally, I got bit super hard by dynamic zone management in like 1998, and I still have not forgiven the software for this. So my zones are static as much as possible. Dynamic zones that are maintained by NSUpdate don't require any special configuration. A static zone does require some special configuration. Generally, you need a place where named can write a modified version of that static file, because it will take that zone and make it dynamic and apply the special DNS Sec gravy. An upshot of this is the serial number may not match what's in your file, but that's okay. Bind now has this thing called a key and signing policy, and it lets you set all sorts of variables that, like, what kind of keys do you want? How long should a signature be valid for or renewed? When should a key expire? What kind of keys should replace it? And you can set all of this in a policy file, and Bind will just do it for you. The default policy uses a CSK that never expires, which for 99% of the zones on the internet is perfectly fine. Mind you, 99% of the zones on the internet are just not very important. I suspect a lot of people sitting in this talk have zones that are important. So how do you actually deploy these? Well, you just set a policy name in the zone description and boom, reload the name server, and suddenly you will see key files in the key directory. And if you start digging at your zone, you will see those key entries and signatures. So when you do that, you can query the name server with RNDC and see what Bind thinks is happening. So it's created a key. That's key tag is 44950, and it's using ECDSA and a combined signing key, and it's been in use. And the DS record, 3 lines from the bottom, is rumored because you haven't really published it yet. But according to named, everything is fine. I would tell you to use dig and dig plus DNS Sec on the zone just to see that you have RR-SIG records. Once this exists, you can publish the DS record. Go to your domain registrar. They will have an interface somewhere that says publish your DS record, add a DS record. Provide them the information they want. You wait for old caches to expire before relying on it. The amount of time that takes will depend on your parent zone's time to live. For .com, if I remember correctly, it's about 6 hours, which is not terrible. Once that's done, tell named that you've published the record and it should be there. So, how do things go bad? If your zone does not validate, you disappear from the internet. Once you have a DS record in your parent zone, your zone must be signed with a matching key. If you publish that DS record before the zone is signed, you disappear and no longer validate. If you remove DNSSEC from the zone while the DS is in the parent zone, you disappear. If you get frustrated, delete everything and start over, but you have a DS record, you disappear. And lastly, a bad clock. There were expiration dates on the signatures. If your clock is skewed enough that it starts to pull those signatures, you will start to see a gradual disappearance from the zone. So, how do you debug this mess? The truth is, real nerds only need dig and date. For the rest of us, there are tools. Use them. So, only two things that you can do break DNS: a key mismatch or an incorrect clock. So, question is, first, is it DNS or DNSSEC? If you make your zone non-authoritative, if you somehow break your zone just at a basic DNS level, your zone will not validate because it's broken. And then you have to sort out things like, it could be a network issue. It does happen. It could even be a bug in the name server. It's not common, but it happens. So let's look at the network. Whoop, I somehow bounced back to the wrong screen. So, DNS originally used small packets on UDP port 53. That has been obsoleted for 23 years. But a lot of bottom-feeding routers, internet devices, naive cable modems, virtual switches do not realize this has happened.
Hey, Michael, your presentation disappeared.
Oh, it did?
Yes.
Oh, thank you. Hang on here. But you're all still connected. Cool. Let's have a new and exciting problem. Okay, are you there?
We're seeing you, but we're not seeing the presentation. Or at least I'm not.
Huh. Okay, I'm sharing another application window. Fine. We stop that. I don't know what it was sharing.
It could be one of those lovely things with 8x8.
Could be. Stop sharing. Okay, am I sharing anything, or you're just seeing me?
I'm just seeing boxes.
Oh. You're seeing boxes as in the
Names of people.
The names of people. Okay. Am I somehow sharing the browser? I'm sharing another application window. Stop sharing. I hate to say this, I think the simplest thing to do is disconnect and reconnect.
Okay.
I agree. Let's do it.
Okay, I'll be right back. Hello, testing 1, 2.
Hello.
Okay, let's try this again.
Hey,
Okay,
the network.
the network. Okay, so since COVID started, I have seen network device GUIs that have tick boxes for allow RFC 2671 DNS that default to off. If you encounter one of these devices, the only thing I can say is that the rest of the device is probably just as awful, and you should beat it to death with a hammer before someone tries to use it for something. It's over 20 years and still. So the way to check your network is with the easy way is the OARC reply size tester. Our first query, reply size is at least 4064, which is good enough. That's plenty. The second one I sent from a VirtualBox VM, and it told me that maximum buffer size was 1232. So if your DNSSEC stops working after, say, someone's done a router OS upgrade, check, because computers do stupid things. So a zone can be in, if it's not your network, your time is right. Everything looks good so far. And DNS works. If you turn off validation, yep, you got a DNSSEC issue. DNS has 3 states. A secure zone has working validation. An insecure zone is authoritative. Basic DNS works, but there's no DNSSEC. A bogus zone has DNSSEC that is broken. And again, there are just 2 causes. The easy way to test your DNSSEC is to use an online debugger. My favorite is DNSViz because it is it's pretty, it's simple, it's easy to understand. I also recommend you use this kind of tool and all debugging tools on a working system first. You need to know what normal looks like before you can try to debug broken. So here we see my zone tilted windmill press. Up at the top, we have the root zone in the top box, and that has a key that is trusted. We have the DNS key record and the DS record that goes down to the .com zone, which has its own DNS key record. When there are 2 DNS keys in a zone, That means there's a KSK and a ZSK. And that has signed the DS record for my domain. And that refers down to the DNS key record on my zone. And everything here is lovely and it works and everything is happy. So let's go poke at another zone. Here is one of my domains, michaelwlucas.com. At this point, there are no DNS key records. There are no DS records. If you look in the .com zone, the parent zone, you will see there's an NSEC3 record. This means that .com is authoritatively declaring there is no DS record for this. It does not exist. And validation is happy because it knows there's no such thing. Move on. It won't validate, but it's not bogus. And here I've gone and I have added a DNS policy to my zone. But I have not published the DS record in the parent. The key exists. The debugging tool sees it. But parent zone doesn't know about it. There is no chain of trust because the parent zone is still authoritatively saying that there is no key. When your zone looks like this, it's ready for you to publish a DS record. And then you'll go back to that pretty zone with the full chain of trust. Something that's broken. Here we have my good buddy DNSSecFailed.org. And you see the chain of trust at the top and the bright red arrows. The DS key points at a DNS key record, but that DNS key is not in the zone. The DNS key in the zone is not connected to the chain. We're broken. This is the problem. So the DS record is pointing at a key tag number 106. The DNS key is tagged 29521. Mismatch. You know what the problem is. Move on. So, fully debugging, top to bottom. Verify the network. Verify the clock. Separate DNSSEC from DNS problems with the CD flag. Now, suppose you finish all that. It's a DNSSEC problem. But you go to DNSViz and it says things are fine. And it works for some people, but not others. It could actually be a client or a software bug. That's when you file a bug report. So, suppose that you're trying to do business with me and I go, oh no, my DNSSEC has gone belly up. I screwed it up. Because, I'm an idiot. But you still have to do business with me, or maybe I'm Ford Motor Company or whoever, some big company that you're dependent on, broke DNSSEC. A negative trust anchor tells your recursive server that I know this zone is bogus, but don't validate it. It's a temporary problem. You turn on, you use our NDC, you tell it to turn on the negative trust anchor for the zone, and it will keep checking every 5 minutes until it does validate. These only last for an hour unless you set a lifetime. So let's talk about key rollover. The longer a key is used, The more data gets signed with it, the more time an intruder has to break it. So if you have data that people may want to steal, again, if you're storing HIPAA data, personal data, stuff you might get sued for, credit card numbers, are you PayPal? You need to change your KSKs and ZSKs periodically. And the goal in a key rollover is to maintain a valid chain of trust despite everybody caching everything. And extra signatures and keys in your records don't matter, so long as any one of them, any combination, creates a complete chain of trust. And there are a couple ways you can do this. There's double signing, where you create a new key, and both keys simultaneously sign everything. And it roughly doubles the size of your zone. The advantage is you only have to talk to the parent zone once. You wait for the new key and the new signatures to propagate. You go to the parent zone. You say, here's my new DS record, kill the old one. And that's the best practice if you're using a CSK or if you're rolling a CSK or a KSK. There's the pre-publish method. And this seems cleaner and more elegant, but it requires more communication with your parent zone. And generally, you only use pre-publishing if you're using zone signing keys. This lets you roll a ZSK anytime you want. So Zsk rollovers, if you got that, how do you deal with that? Well, your zone's Zsk is signed by your zone's KSK. This happens entirely internally. The outside world is not involved, so you can roll anytime you want. And rolling your Zsk does provide additional cryptographic security. Csk and Ksk rollovers are a little more complicated. You got to talk with your parent zone, your registrar. You must update the parent zone and allow new records to become omnipresent before killing your old keys. This involves timing and verifying TTLs. There are gory details in the book. This is not hard if you manage DNS and caching routinely, but it's just annoying. So the question comes, how often should you do these KSK and Zsk rollovers? There is strong disagreement here, but it all comes down to what is your threat model. There are people who say you must rotate your KSK every 3 months. There are people who ask, how often do you rotate your SSH server keys? But really, what is your threat model? Your personal website? Maybe never. If you are a valuable target, I would tell you yearly. And when an algorithm is deprecated, you must rotate. For example, once upon a time, you could sign zones with MD5 hashes. This is no longer viable. In general, here's my opinion. Feel free to argue with someone else. Any process that is never exercised decays and becomes scary. If rotation is something you have to do it at least yearly. What you don't want to do is be in the position where you say, this key was rotated 12 years ago, and we have to rotate it now. Because that is a horrifying situation to be in for anyone. You do not want to be there. So how How do you roll over? Well, DNSViz is your best friend in this. At some point in the rollover, it's going to look like this. You'll see the two records pointing down. And that may be your friend, but patience. Patience is everything. If we were here in person, I would ask for a show of hands of how many of you remember when AOL first got on the internet and thought they would save. Whoop, that was a strange sound. Have I disconnected?
No, that was me raising my hand.
Ooh. Let me finish the question and then raise your hand. Do you remember when AOL violated the DNS caching timeouts and kept the expired stuff thinking that they would save on bandwidth? I used to work at a global internet backbone, and this was a horrifying nightmare. So, and one day, some bright boy is going to reinvent that horrible idea. So give everything extra time. You know, perhaps you could theoretically roll the key in 6 hours. Give it a day. Give it a day between steps. Relax. Don't rush. Unless you have to rush. Suppose your private key has been compromised, and you find you've got to hurry up and do a rollover in the minimum possible amount of time right now. Well, again, DNSViz is your friend, but impatience is your spouse. And the short answer here is suck it up and do it. There are two ways. You can pull the DS record and make the zone insecure. You can live with sporadic problems while performing the rollover. Either way, caching is going to stab you. Whatever horrible method you choose, use this to go to your boss and say, look, if we had bought a hardware security module and put it on a stealth primary, this would not have happened. And you will get your answer. You will get your equipment. So, what other things can you do with DNSSEC? You can delegate to your own child zones. You can serve up DS records for other people. You can do DNSSEC on wholly internal zones. Say you're using 10 addresses or 192.168 internally. You can secure those with DNSSEC in an island of trust. You can distribute application data over DNS. Your OpenSSH client, we are all sick of seeing the message that says, this is an unfamiliar host key, please verify it matches what you expect. Well, DNSSEC lets you automatically distribute that to client and store the keys in DNS, and boom, OpenSSH just takes it. VPN key configurations can again go into DNSSEC or DNS records once they're signed with DNSSEC. There's also something called TLSA, which lets you verify X509 certificates through DNS. Again, if you are doing anything with an internal zone, register a real domain. They are cheap. I know of 4 different organizations that decided that they were going to use the .int top-level domain internally, and then discovered that was a real domain in the outside world. Don't do that. Buy a domain. So, I'm going to open the floor to questions and answers. If you want any more on DNSSEC. The book came out. There's lots more books on my website. And dear IRS, this makes my internet connection deductible. So deal. And that is a talk. So, any questions?
I do have a question, please.
Okay.
It's when you talk about Island of Trust and the fact that you can sign something that is not connected to the root, is that something that is explained in the book? I may have missed that. I have the book somewhere,
it is explained in the book. Pardon me, I'm just getting some light. Let's see if that is a little better. That's as good as it's going to get. Yeah, that is explained in the book. And it's pretty straightforward. You define your own trust anchor. You configure it in your recursive resolvers and go.
Okay, thank you.
So how much would you recommend folks do DNSSEC? Let's say that I've got, my home, my domains and whatnot that I have out there that are mostly for personal stuff. Should I worry about this, or should I start diving in?
Well, this is a long argument that is best had over beer. There are people who would tell you that yes, you must. There are people who hate DNSSEC and say no, don't bother. My personal opinion is that signing your zone with a CSK is a one-time thing. And it is hard to say that you will never be targeted. We live in a world where if you open your mouth on Twitter, you can get dogpiled very easily. And some people deserve the dogpile. Some people have typos. And DNSSEC is a low-cost way to lock down your domain. So I would tell you to do a simple configuration with a CSK, and stand by your words, whatever they are.
So should I then maybe do it on a subdomain first to make sure that everything is a-okay, or?
Well, I would tell you to do it on a test domain because you need
Right.
a complete chain of trust.
Right. Okay.
So
I should use it on one of the knockaround domains that I have for someday,
right.
maybe. Right.
I'm pretty sure that just about everyone on this call who has domains has trash domains.
Or the domain that will eventually become a project at some point in the future.
Yes.
Maybe.
I mean, for the TLS book, I needed a domain with certain characteristics, and I wound up registering. You keep using that word. I do not think it means what you think it means, .com. And that poor domain has experienced some terrible things.
Yeah, I have a knockaround domain that I just typed in there, so I'll probably use that.
Yeah.
That is eventually going to be a project at some point, maybe.
Absolutely.
Could we talk for a minute about the reasons you'd want to do this? What by not securing your domain, what are the things that can happen to you?
The short answer is DNS is gullible. An intruder, a malicious actor, or just a flat-out configuration can insert bogus or incorrect data into a recursive name server very easily. That's the purpose of a recursive name server, to accept data from the public.
Right, but let's talk about what that means. I mean, why is that a problem if somebody inserts bogus domain information into my name server?
Well, let's say...
I think I've got an idea, but I'd like to hear your reasoning behind it.
Let's say you are running a medical records company.
Mm-hmm.
And someone gets to the name server that your client uses, their recursive name server, and they put a bogus record in for your domain.
Mm-hmm.
Anytime that client wants to reach your website, they go where the intruder wants them to go.
Yes, they're going to hit a different...
They're going to hit a different server.
Hosting a website. But won't a SSL certificate help you there as well? They're going to hit a server that...
It depends on how things work, what the client has done.
Okay.
With an educated user, I would like to say yes.
Yeah. They may not notice
they may not notice.
Okay.
They may not. I would tell you that when 95% of users get a pop-up in an application and it says, there's a problem, should I continue anyway?
Yeah.
They say, yes, continue. I just want to get my work done.
Sure.
And the computer always fails.
So by leaving your DNS server, your name server vulnerable, somebody could insert a record that directs people to a different site when they think they're coming to mine.
Or suppose they attack a service that is not the web. What if they hit
a RESTful API or something like that?
An API, your mail exchanger.
Sure.
The world is not the web.
Yeah.
Suppose they insert a record that says, hey, these are the valid fingerprints for my website's TLS certificate. And it doesn't match what you've done. Some browsers verify those. I expect more will at some point here. That has turned into a political issue, not a technical one.
Mm-hmm.
And eventually, one of the two parties involved in the argument will give up and the other will win. That's really what the browser vendors are waiting on. At that point, your website becomes unreachable because the client says, hey, this certificate is invalid because someone poisoned your data. So MX Records, you have an A record for your website. Are you running IPv6? If not, and an intruder adds a quad A record, well, Windows now prefers IPv6 over IPv4. And that IPv4 record is valid. They can get a Let's Encrypt for that quad A record. So, we're living now. Intruders are patient and persistent, and there is a bounty on some of you.
Well, even so, they could also poison it so that you become unroutable. at some point. So basically,
Yes.
you just go off the network.
Yeah, sure. They can do a denial of service as well.
Yeah.
Yes.
And you get to wait 6 hours for it to all sort itself out.
Yep. Except they run their script every hour to refresh the cache. And how are you going to contact Google and tell them that they have cached bad data for your domain? How are you even going to find which of the dozens of servers at 8.8.8.8 has bad data?
Mm-hmm.
And what are your service level agreements for your site? Now, Craig, I don't know. I suspect not very high for most of his stuff. If you're running a business and you have customers and they expect your site to be available, spoof DNS, well, should this get into court, they will ask you, why did not take the industry standard precaution of securing your DNS?
Sure.
And it's fairly straightforward.
So I want to buy your book.
Oh,
Should I go to Tilted Windmill Press, or should I go to Amazon?
do you want it in print or as an ebook?
Oh, that seems like a good book to have on my shelf.
Okay.
Why not both?
Okay. So both. So both, yeah.
Yes, print you can buy from any print bookstore. I do have a print bookstore, but you have to pay shipping, I'm afraid.
Okay.
So those are for people who, the print bookstore is for people who really want to suck up to me, and I love them all.
Let's assume I'm one of them.
There is a link on my website. Wait a minute, we have a chat.
We do have a chat, but we also have people that are on YouTube that may not have access to the chat.
That's great.
So saying it out loud may help them.
If you go to mwl.io, one of the first links is my print bookstore. And yep, there is actually the fourth paragraph starts with find my nonfiction books at my ebook store, my print bookstore.
There you go. Okay, good. Good.
He also has a Patreon as well. So if you like to patronize him, we all like to patronize Michael as much as we possibly can.
I even have a disintermediated, a direct Patreon.
Yes.
Which deprives the fine folks at Patreon of their cut of my income and makes their children starve. So
look at that. You even do a hardcover. That's great.
So yeah, you can head to tiltedwindmillpress.com. That's tiltedwindmillpress.com, which also probably makes a very good password. You can also go to shop.aer.io/MWL, and that will get you to the print bookstore.
Yes. Excellent. Because I enjoyed your talk very much, but I need the book.
To do it, you really need a more detailed.
There's a lot there.
There is. It is not that. Once you set it up, it basically runs itself.
Sure.
And speaking of which, we also, if you fill out the comment card, you can be eligible for winning some of the other fine books from Michael Lucas.
Yeah.
So please fill that out, and we will send you a copy of one. I'll send you a list of the books. We do not announce the winner. Michael does not want to know who the winner is. So we will contact you quietly and offline to let you know what's going on. We do this very secretly. It's security. The 3 S's.
I just told Craig that I'd be happy to have him give away an ebook at every meeting, but I didn't want them to bother me about it. And
Exactly.
He's taken that very much to heart.
Yes, exactly.
So I've got another DNS question for you, since you're here. In the past, I've seen people run their primary and secondary DNS servers on machines side by side, on virtual machines running on the same host. Ridiculous things like that.
Yes.
And I tell them they're idiots. I've gone the other extreme, and I've got my primary DNS server in my data center. My secondary is running on a friend's server down in Brazil.
Mm-hmm. This is the way.
There's likely not going to be a natural disaster that will take both of us out at the same time.
And if there is, it's not your problem anymore.
No, there's bigger things to worry about.
Yes.
But I don't know if that friend can do DNSSEC. I will ask him.
Well, here's the thing. He doesn't have to. It's just records in your zone. Your friend needs no special configuration.
Well, but he's going to do zone transfers.
Yes.
Right. Couldn't his system be vulnerable?
Well, if someone hacks into his, remember, separate authoritative and recursive servers.
Okay.
The recursive server has the job of accepting data from the internet, from the unwashed masses of the public.
Sure.
The authoritative server, which includes both the primary and the secondary, has the job of not listening to a dang thing anyone says. The zone transfer comes from a trusted source. The contents of the files are digitally signed. Nothing is going to happen there. Now, if your friend has specifically configured his server to be both authoritative and recursive, please politely educate your friend on why this is bad.
He's very, very smart, but I need to look. I will double check.
Yeah.
But let's say he's a great friend, but let's say we have a falling out and he's no longer going to serve my DNS.
Yep.
Where do you go for a secondary DNS server?
Well, is he your only friend?
No, but aren't there services out there to do this?
Yes, there are absolutely services. There are people who will secondary you. There are people who will let you treat your authoritative server as a stealth master and just take the digitally signed records and distribute them and be your public face.
Okay. That seems reasonable, but maybe excessive for me. But I may be in the market for a new secondary DNS server.
Yeah.
You could probably set up something with Linode or something like that, because I know they do my DNS for most of my stuff. I shouldn't say that out loud, probably. But yes.
When you say they do it, you mean Linode is running a service, or you're running an instance of Linux on a Linux?
They're running a service for me so that I don't have to think too hard about DNS.
Okay.
Yeah, lots of people will. I mean, I have stood up $5 a month VMs on over in Europe.
Sure. Okay. Well, good.
So, yeah, there are, and most of the services are priced somewhat reasonably, so long as you avoid anything with the word enterprise in the name.
Or daddy.
Oh, is it? Yeah, right. Is it Amazon that's got like Route 53 or something? Is that
Amazon has their, yes.
Is that a viable choice, do you think?
Well, You would really want to talk to someone who uses those services.
Okay. Okay. Yeah.
Since I write books on this stuff, I feel obliged to actually run my own servers.
Sure.
I mean, that's how I get expertise.
Sure. 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 I mean, who's going to trust you if you're writing the books, but you're dependent on Amazon to handle your DNS?
Right.
Yeah, I get it.
Cloudflare has some stuff. I don't know if they do DNS.
I believe they do.
I bring up Amazon because I've already got an account there doing some other stuff with AWS. That's all. Cloudflare, I don't have a relationship with them yet.
I thought I saw that they had a free tier for some stuff.
They do. In general, in the free tiers, the provider is harvesting your query data for marketing purposes.
Yeah.
So depending on your business, that may or may not be acceptable.
It appears free.
It appears free. But if you, again, FERPA, HIPAA, any of these privacy laws we have may contraindicate using the free tier.
Sure. And the cost isn't that much anyway.
Yeah.
I assume.
I just checked, and apparently there is a long-standing forum community thing for Linode where they do not support DNSSEC at the moment. So that is a slight downside for them. So you probably have to spin up your own VPS then.
Yeah.
To do that.
Then, yeah, then you are your own secondary. Sure.
Anyone who can secondary can do that.
Yeah. Just don't run them side by side.
Yeah.
Yeah. It's funny when the .1 is the primary and the .2 is the secondary.
Yeah.
I assume don't run them side by side would mean don't run both of them in Linode either.
Well, that kind of depends.
Unless you're sure they're in different
Well, don't run them on the same machine, that's for sure.
If Linode has regions.
Different zones. Yeah, you can use different zones for hosting.
Yeah.
Okay.
AWS, Linode, whatever. As long as you're picking different zones, then you're going to be covered.
Okay.
Yeah. It is possible that when something happens like AWS goes down, the world knows. That hits the Wall Street Journal.
Sure. If you can get to the Wall Street Journal when it goes down.
Yeah.
Yeah.
I use Vulture for mine. I have one on the East Coast, one on the West Coast. It's solid enough for me.
Sure.
Are there any other questions?
Anyone want to call me an idiot?
No.
Prefer not to.
There is no reason for that.
Yeah, I'm not going to venture into that.
I'm not near smart enough to call you an idiot.
Oh, no, there's a special kind of idiocy available only to smart people.
The value of hubris. So once again, the sites are tiltedwindmillpress.com and shop.aer.io/MWL. That will get you situated with all sorts of wonderful stuff from Michael Lucas. Not only does he have all the technical books, but he also has very wide selection of fiction books like the Prohibition Oryx, Immortal Clay, and the series that I cannot remember, and Get Commit Murder as well, which is a fiction story about a murder that happens at a convention, a technical convention. So if you want to read something that hits a little close to home, this is definitely it. If you want to voyeuristically go to a convention and have bad things happen, this is also another way to do so.
And I put the link for my website in the chat. It's mwl.io. And that is a treasure trove of smart idiocy.
And if you haven't done so already, please scroll up in the chat window to find that link for the
I'll
survey.
post it once again.
Yeah.
Because scrolling can be hard and finding things can be
Yeah.
difficult.
Yeah. So Craig will post it again.
Uh,
Click on that.
Is there
Yeah.
anything
assuming that Chrome